Good day everyone. Today we will be discussing about the Pert-Cpm or the critical path method, which is the CPM, and the PERT program evaluation review technique. These two options is very important for project scheduling. First, let us know what is project scheduling. Project scheduling is the process of planning and organizing sequence of tasks in project to ensure everything is completed efficiently and on time. And it helps determine which task must be done first and which can be done at the same time, and which task is the most critical that needs to be finished based on the schedule. The importance of the program evaluation review technique, or the PERT, and the CPM critical path method is this project planning. The project planning lies in their ability to help managers organize and schedule and monitor complex projects more effectively. These tools allows planners to visualize the sequence of tasks, determine which activities are most critical and which activity is the most important for the success of the project.
We will discuss about PERT. So what is PERT? Program Evaluation Review Technique. PERT is used when task durations are uncertain. It uses 3-time estimates: optimistic, most likely, and pessimistic. For each task, to account this uncertainty, PERT diagrams are typically activity on arrow or AOA, visually representing the flow of activities. It's commonly used in research and development and innovation projects. Next is we're going to talk about CPM or critical path method. CPM, on the other hand, is best suited for projects with predictable task durations. It focuses on identifying the critical path, the longest sequence of dependent activities that determines the shortest possible project durations. CPM diagrams are usually activity on node. It's frequently employed in construction and production projects.
Good day everyone. Today we're gonna talk about activity on node diagram, or AON. So what is AON? AON is a project management tool used to represent the sequence and dependencies of activity within project. In this diagram, each task or activity is presented by a node, typically a box, and arrows between these nodes indicate the order in which the activities must be performed. The arrows reflect dependencies, showing which tasks must be completed before others can begin. The most common type of dependency is finish to start, meaning one activity must be completed before the next can start. So, for example, for this is you need to finish the first activity nga imong ginabuhat before ka mag-proceed sa next activity. However, other types such as start to start, finish to finish, and start to finish can also be presented. AON diagrams are widely used in methods like critical path method (CPM) to help identify longest chain of dependent tasks that determines the minimum project duration. By clearly visualizing task relationships and durations, AON diagrams assist project managers in planning, scheduling, and monitoring progress, ensuring efficient resource allocation and timely project completion.
Good day everyone. Today, I will be discussing about the activity on arrow or AOA. AOA is a network diagramming method where each activity is shown as an arrow, and each node or a circle represent an event, specifically the start or end of an activity. It is used in PERT and CPM for project scheduling. There are key elements of the activity on arrow. First is the activity or the arrow. Represents a task that takes time and resources, shown as a direct arrow. The second is the node or the event. Represent the start or end of one or more activities, shown as circle. Then the last is the dummy activity, a dash arrow with a zero duration used to show dependence without a real work. This dummy activity is lain ni siya sa AON. Kaya ang AON kay wala siya dummy activity. Mo ni siya ang kalahian sa AON and AOA.
To further understand, we have an example. We have 6 activities: A, B, C, D, E, and F, and the predecessor and time and weeks. The predecessor of A is none, and the time needed is 3 weeks. The predecessor of B is A, and the time needed is 5 weeks. And the predecessor of C is A, and the time needed is 7. And the predecessor of D is B, and the weeks needed is 10 weeks. And the predecessor of E is C, and the time needed is 5 weeks. And the predecessor of F, D, and E, and the time needed is 4 weeks. And then we have to construct an AON diagram or activity on node diagram. Since the A don't have the predecessor, so we put it first because this is the first start of the activity. And the predecessor of B is A, so the arrow will connect it into A, and the predecessor of C is A, and also the arrow will connect to the C. And D is the predecessor is B, so the arrow will connect it to B, and the E is the predecessor is C, so we connect it to C. And the F is the predecessor of F is D and E, so the arrow will be in D and E. And that's all.
After constructing the network diagram, the next thing to do is to do the forward and backward pass. So the forward and backward passes are used to calculate the earliest and latest start and finish times for all project activities, which is crucial to identify the critical path and managing the project schedule effectively. So before we proceed, let me first explain the parts of a node. So, itong letter na nasa gitna is ito yung activity, while ito namang number na nasa ibaba is ito yung resources or time. Ito namang ES, which is the earliest start. Pag sinabi natin earliest start is ito yung pinakamaaga na magsisimula ang activity. While ito namang EF or the earliest finish is ito naman ang pinakamaaga na matatapos ang activity. While ito namang nasa ibaba, ang LS or the latest start, ito yung pinaka-late na magsisimula ang activity pero hindi niya madidelay ang buong project. While ito namang LF, which is the latest finish, is ito yung pinaka-late na matatapos ang activity pero hindi niya madidelay ang buong project. So let us now proceed to the step which is the forward and backward pass. So the activity A and its corresponding time, which is 3 weeks. Since activity A is the start of the project, maglalagay tayo ng 0. Every start of the project is ang equivalent value nito is 0. To determine the earliest finish is ang gagawin lang natin is i-add lang natin ang earliest start, which is 0 sa resources or time, which is 3. So, 0 plus 3 equals 3. Mukha lang siyang inverted triangle. Dito naman tayo sa activity B. So, since ang predecessor ng activity B is A, and natapos na ang activity A, mag-proceed na tayo sa activity B. To determine, so, ang gagawin natin is i-transfer natin ang EF value, which is 3, sa ES ng activity B. And then, same process, i-add lang natin ang ES sa time.
So 3 plus 5 is equals to 8. The same procedure sa activity C since ang predecessor naman nito is A. So, ang value na 3 is ita-transfer natin sa activity C. So, same process. 3 plus 7 is equals to 10. And then, sa activity D naman, same ulit. Ita-transfer lang natin ang value sa earliest finish ng activity B sa earliest start ng activity D since ang predecessor ng activity D is B. So, 8 plus 10 is equals to 18. Same process sa activity E, but ang value na kukunin natin is sa activity C since ang predecessor ng activity E is si activity C. So, 10 plus 5 is equals to 15. So, dito naman tayo sa activity F. Notice na ang predecessor ng activity F is both D and E. So, ang gagawin lang natin is may rule ito. Sa forward pass, kapag sa forward pass, ang gagamitin nating value is yung highest value. So, between the 18 and 15, ang mas higher value is ang 18. So, ito ang gagamitin natin. So, 18 plus 4 is equals to 22. So now, what does the network tells us? We could say that after completing the forward pass is that the project could be completed in more or less 22 weeks or at least 22 weeks. We have that estimate on when we could or possibly finish the project. We actually term this as the most likely to finish the project, and this will be further discussed by the next reporter. Okay, so now, as we notice, there are still empty cells. We still don't have the latest start and the latest finish. Para malagyan natin ang nasa baba, we will now do the backward pass, which is the next step, and it will be discussed by the next reporter. Thank you.
To continue, backward pass, we will start at the right side. Copy the EF or the earliest finish down to the LF or the latest finish. To determine the latest start, we're going to subtract the LF and the time since the rule in the forward pass, you should add it. But in the backward pass, you're going to subtract. So 22 minus 4 equals 18. Then the same procedure. Sa forward pass, copy the LS to the previous LF activity. Same procedure, subtract and copy again. The LS to LF. And the activity A, notice that it has two values from activity B and C. What we're going to do is copy the smallest value and then subtract. And that's it. And there you have it. That's all. Thank you.
Let's solve how the PERT or the Program Evaluation Review Techniques is solved. So, how do we do that actually? Let's identify the project activities and the time estimates. The first one we're looking is the optimistic time, which is the earliest possible time given to allow work. The next one is the most likely time or the most realistic possible time you can finish your work. And the last one is the pessimistic time. That is the longest possible time you can finish your work. And here, I'm here to show you the formula of the PERT or the Program Evaluation Review Techniques. As we can see here, we can see the O represents the optimistic time, and there's a constant number there, which is the 4 and the 6. But first, let's go to the 4. The 4 is where you multiply the most likely time, which is any given number from the most likely time, which is M right now. And here comes the last part, which is the pessimistic time, that would be your final addition from the optimistic and the most likely time, that is multiplied by 4 and add last but the pessimistic time. And after that, let's divide it by 6 to get the average time given to your answers. Following from the last example, I'm here to show you the next example, which is the table that is missing an optimistic time and the pessimistic time and only given the duration of the weeks that are the actual time. So here, I'm here to show you on how to solve the optimistic and the pessimistic time. The next page here, as we can see that there are tables from pages 9 or something that it is similar to the forward and backward pass. As we can see here, the table is consisting only the letters or the activities and the duration of its time from A to F, and then its predecessors of B and C to D and E until F. So here, the next example is how we solve the pessimistic and the optimistic time. As you can see here, the A starts with 0 of the optimistic time because we are starting at 0 time. And then as we can see here, on how we get 3 on the pessimistic time, it's just because we added the optimistic time and the actual time given, and so on and so forth. So as we can see here, at the right, at the left, at the final table, which is F, we can see here that the optimistic time is the D, or the highest number you can find from D table and E table. Here at the next page, we can see that there are the formula. From A, we need to start at 0 plus 3 and times by the constant 4 and plus the pessimistic, which is 3, and that's it, divided by 6, giving the answer of 2.5 weeks, and so on and so forth until you get to the table F, or the formula of F, which is 18 plus 4 times by 4, which is the constant number, and then plus 22 divided by 6. Hence we get 9.33 weeks, or 9 weeks and 2 days.
Good day everyone! Today, we are going to talk about how to solve a CPM problem. But before we proceed, let us first understand what is CPM. CPM, or Critical Path Method, is a project management technique used to identify and schedule the most critical tasks in a project, ensuring it is completed in time. In short, CPM is a technique used to identify the most crucial sequence of dependent tasks, or the critical path, that determines the total time the project will take. It also helps in planning, scheduling, and managing complex projects. And to apply critical path method, we take a simple 6-step process. First is specify each activity, so you have to clearly define each individual task or step within a process, or including how long each task takes and which task must be done before others. It is also called as predecessor. Next is sequence the activities. So sequence the activities, ang example ano is nasa makita sa slide sa activity on node. So sa activity on node, na ito ka sequence ang activity A, activity B, activity C, activity D, E, and F. And then next is draw a network diagram. Draw a network diagram is similar na siya sa step 2, which is sequence the activities. Ang ilang difference lang is ang diagram kompleto na siya, na siya duration. Unlike sa sequence is iya lang activities. And then next is estimate activity duration. Activity duration, time required to complete individual project tasks. And then fifth is identify critical path, or the longest route through the project task. And then next is update to show progress. Use your critical path as a monitoring tool and to update it to show progress.
Good day everyone, I am Janelle Rica Humalan and I will be showing you the step-by-step solution of a Pert-Cpm problem. Pert stands for Project Evaluation and Review Techniques. It is a project management tool used to estimate the project duration and identify critical path. And critical path helps you determine the sequence of activities that affects the total project duration. So let me begin by introducing a problem. Claire, a project manager, is setting up a new production line in a food processing facility. She has identified 8 major activities labeled A through H. Each activity has an estimated optimistic time, most likely time, and pessimistic time, as well as specified predecessors activities. So, our goal is to calculate the expected time for each activity. Second is create PERT chart to visualize activity flow. Third is determine the earliest and latest start and finish times. Fourth is identify any slack or flow time. And finally, find the critical path and expected project length. The first step is we calculate the expected time for each activity using the formula TE is equal to O plus 4M plus P over 6. Now, let's apply this formula to each activity. For example, for activity 1, TE is equal to 1 plus 4 times 2 plus 3 over 6, and that is equal to 2 weeks. And then after calculating for all activities, we get the following expected times as shown in the table. Second step is we have to draw the PERT diagram using the dependencies provided. So activities A and B start first. A leads to C and D, B leads to E. Both C and D must be completed before F, and E leads to G, and finally both F and G must be completed before H. In step 3, we'll do the forward pass to determine the earliest start and the earliest finish for each activity. So the formula is EF is equal to ES plus TE. We begin with ES is equal to 0 for starting activities, and for dependent activities, ES is the maximum of all immediate predecessors.
Now, based on our last activity, our activity H is with a latest finish of 17. Our formula is latest start is equals to latest finish minus estimated time. Moving on to the step 5, we compute the slack. Slack is the amount of time an activity can be delayed without affecting the project. Our formula is slack is equals to latest start minus earliest start. Activities with zero slack are on the critical path. Now for the step 6, we identify the critical path. First, what is critical path? The critical path is the longest path in the network. It determines the minimum project duration. It includes only activities with zero slack. Our critical path based on our activity is A to D to F and then H. Our expected project length is 17 weeks. In conclusion, we use the Pert-Cpm to calculate activity times, determine dependencies, and identify slack, and ultimately find the critical path. This process allows project managers like Claire to manage timelines efficiently and ensure timely completion of key activities.
So we've explored everything that needs to be tackled down in this subject, and the topics is, I don't know if it's well versed or anything, but if you're listening, thank you for listening, and please support us. That is all. Goodbye, everyone.